Yo, 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 what's going on? Let's keep rolling on here. Now we're going on to chapter 9, starting with section 1. And so we're going to move on to some other awesomely nerdy topics. Much fun here. Okay, so we're going to talk about the square root property and completing the square here in just a minute. And this chapter is about mainly solving quadratics, okay? And so let's just go over what is a quadratic and all that kind of stuff here. So a quadratic is some kind of function that has a power of 2, meaning it has the general formula like this: ax squared. Oops, if I can do that correctly. Let me try that one more time there. Let's try that again. Ax squared plus bx plus c. So basically this square term right here, x squared, that's what makes it a quadratic, okay? Okay, if it has a power of 2, we call this a quadratic, all right? And so in this section, we're going to be talking about solving quadratic equations, all right? Now, this book is just a little bit disjointed in that normally you would graph the quadratics first and then solve quadratics. That's what it's usually normally taught. But so let me just, a quadratic, if you were to graph them, they're always going to be in the shape of a parabola or of a U. Okay, and sometimes they open up or sometimes they open down. Okay. So when you graph a quadratic, they look like this. They're a U shape going up or a U shape going down. Now we don't actually graph quadratics until chapter 10, so that fun will have to wait. But I'm showing you this right now because when we solve quadratics, and that's what we're going to do right now, when you solve a quadratic, okay, you actually are finding what we call the x-intercepts or the roots. Okay, so wherever our parabola or wherever our quadratic crosses the x-axis, those are called the roots. Okay, so that guy right there and that guy right there. Or you can call it the solutions. Or you can call it the zeros. So really, the x-intercepts, or I guess you could call it the x-intercepts. Sorry, that's a lot of words there, but you can say either one of those 4 words, and they all mean the same thing. The roots, the solutions, the zeros, or the x-intercepts all are referring to the same thing. It means where does our quadratic cross the x-axis? So same thing right here. Where does the quadratic cross the x-axis? So in this entire chapter, pretty much, we're going to be learning different methods of finding the same thing. The whole time we're trying to find these little babies right here. Where does our parabola, again, you could either use the word parabola or quadratic, okay, or quadratic, they're synonyms of each other. Where does our quadratic or where does our parabola touch the x-axis? Okay, so I just want to give you a little bit of context so you know what are we doing and what's the context of solving these, all right? All right, so let's see if we can do our first example here. Oops, I'm going to go here. So first of all, we need to know what is the zero factor property. And actually, you learned about the zero factor property in, let's see, chapter 6, I believe. All right, when you factored and then when you solved your factors by doing the zero property. And the zero property is just this. If I know that some number a times some number b equals 0, if that's true, if a times b is 0, then we can conclude that either a must be 0 or b must be 0, right? And we know that because if you multiply anything by 0, it's always 0, okay? So we're going to use this property right now in this first example, okay? Okay, here we go. So we're going to solve by using the zero factor property, okay? Again, we know that since this is a power of 2, that this is a quadratic, okay? And when we are solving quadratics, okay, this is what I want you to understand. When you solve a quadratic, literally we are finding the x-intercepts. That's what we're finding, if you read this section in the textbook, it's not going to give you that context yet. You have to wait until chapter 10. I just want you to know what we're finding. We're actually are finding the x-intercepts of our parabola. Okay, so the zero factor property states again that if I have a times b equals 0, then either a equals 0 or b equals 0. Okay, that's true, right? So we want to apply that same technique to this problem over here. And so basically we want to set this equal to 0. Okay, so that means you want to move this -1, and I'm going to add 1 to both sides. So now we have 2x squared minus 3x plus 1 equals 0. Oops, plus 1. Okay, so this is kind of like, this is going to be our a and b, and this is going to be 0. But the problem is that what is a and what is b, right? Again, a times b means multiply. Well, these aren't being multiplied, so that's why we have to factor right there. That's why it says we need to use the factor property. Okay, so you also learned in chapter 6 how to factor this. All right, and there are a ton of different ways of factoring. So I'm going to show you a method that I like to teach, and it may be different than the way that you were taught, or it may be the same way. If you already are fluent in factoring and you kind of have your own method and you learned from your previous professor, then you go ahead and do that. But maybe you kind of like the way that I'm going to show it right now. Okay? So I guess you could say this is kind of like now a review now, because you learned how to factor in chapter 6. Okay, so we need to factor this. Okay? And so let's go ahead and do that now. Okay, so when we factor, and this is called a trinomial because we have three terms, 1, 2, 3. All right, and when this leading number, okay, is bigger than 1. Okay, so when it's bigger than 1, if I could spell then, okay, when it's bigger than 1, then we have to use this method that I like to call the modified judo. So watch this. You do a judo x, what the? You put the last number on top, put a 1. And, oh no, I'm sorry. You have to multiply. You need to multiply the first and the last number there. So I'm going to go ahead and multiply the 2 and the 1, and that's how I'm going to get my top number. So I'm going to get 2 right here. And then you need to take the middle number and put that one on the bottom. So this -3 is going to go on the bottom. And that's the way it actually always works. You always multiply 2 and 1 to get 2. And the -3 goes on the bottom right there. Okay? So -3. Okay, so now we have to find two numbers that multiply and give us 2, and we add to get -3. Well, wouldn't that give us -2 and -1? -2 times -1 is 2, and -2 times -2 plus -1 is -3. Okay, so now what we're going to do is I'm going to rewrite this. Okay, I'm going to rewrite it. So I'm going to write 2x squared. But instead of writing -3x, I'm going to write it as -2x minus x. Isn't it true that -2x minus x, isn't that -3x? And if you're wondering, where did I get -2x and minus x from? I got it from right here, you see. See, we're here, -2x and then -1x. So really, these numbers are replacing this middle term right here, you see. And then bring down the 1, so plus 1. Okay, so notice that I just rewrote this in this fashion where I put the 2x squared right here. I rewrote -3x as -2x minus x, and I rewrote 1 down here. Okay, now what you do is you factor this now by grouping. All right? The way that you factor by grouping is you put the first two terms in parentheses, and then you put the second two terms in parentheses. Now let's factor out the GCF. The GCF of 2x squared and minus 2x is -2x. All right, so that means -2x times what is 2x squared? Well, isn't that just going to give us x? And then, actually, let's just pull out a positive 2x for right now, and then we'll see if we need to pull out a negative. Okay, so 2x times x is 2x squared. 2x times what is a negative x, or is a -2x? Well, isn't that going to be -1, right? So this times that gives us 2x squared. 2x times negative 1 is negative 2x. Now here, okay, notice, okay, watch this now. I want this to be the same as this. So I'm going to pull out a negative 1. And let me just show you this right now. Negative 1 times positive x will give us this. And a negative 1 times a negative 1 will give us positive 1. Okay, so notice this here. This must be the same as that, and that will always happen. So that's why I had to factor out a negative 1. If I only factor out a positive 1, I would have a negative x and a positive 1, which is not the same as this. Okay, so since both of these guys are the same, then that means that's one of my factors, x minus 1, because I'm pulling those out. And then look at what I have left. 2x minus 1. Okay, and there we go. So now we just factored this guy right here. Okay, so a little bit of work there. You may or may not have learned that method. There are at least 5 or 6 ways that you can factor. And if you need more factoring examples, then please email me and I can create some more videos for you and I can send them your way. Or maybe I can even put them on Blackboard. All right. So I could replace now, watch this now, I can replace the 2x squared minus 3x plus 1 with this guy. Okay, so that means this is x minus 1 times 2x minus 1 equals 0. Okay? So now I'm going to use the zero property, the zero factor property, because look, we can think of this as our a, and we can think of this as our b. Okay? A times b equals 0. Remember we learned that means either a must be 0 or b must be 0. So we set this factor equal to 0 and set this factor equal to 0. So x minus 1 equals 0 and 2x minus 1 equals 0. All right, cool. Now we go ahead and solve. So I'm going to add 1 to both sides. So x equals 1. So that's one of our answers. And then I'm going to add 1. So I get 2x equals 1. And then I'm going to divide both sides by 2. And I get x equals 1/2. Woo, Billy! That was quite a bit of work there for that little dude. So this will be our solutions, 1 and 1/2. And again, what does that represent? It represents the, I thought I had a little graph up here, but basically it would represent that it would cross the x-axis at 1, and then it would cross like at 1/2. So it's probably going to look something like that going up. Okay.